Hello class, welcome to the lecture video on section 6.8, hypothesis test, mean of paired differences mu d. Now for this lecture video we're going to examine two cases. The first case is with small sample and then the second case will be when we're working with a large sample. So let's start off with looking at a small sample case example. So for example, the manufacturer of brand A tires claims that their tires last longer than brand B tires. One tire of each brand is mounted on the front ends of 6 randomly selected cars. After 10,000 miles, tire wear, meaning the amount of tread reduction, was measured by thousandths of an inch. Does the data support the claim of the brand A manufacturer? Use alpha equals 0.05. So in order to use the following test, the differences must be normally distributed. We will assume that the differences are normally distributed, and we will compute our differences d equal to a minus b for each car. Thus, a negative value of d indicates less wear for brand A tire. So to follow our 7 steps, step 1, our null hypothesis would be mu d equals 0. Our alternative hypothesis would be mu d is less than 0, and our alpha value would be alpha equals 0.05. Whoops, I wrote that twice. Step 4, collect our data and calculate our test statistic. Now, for you guys, this will normally just be given for you, but you will have to calculate your test statistics. So for cars 1, 2, 3, and 4, we have our values for A and B. By subtracting, we have our difference column. Now to find our D bar, or the average difference, we add them all up, which we would get negative 38 divided by our sample size of 6 to get our average difference to be negative 6.33. Next, we need to calculate our sample standard deviation, which if you recall would be the square root of the summation of d squared minus the summation of d squared divided by n, all divided by n minus 1. Some of you are still making this mistake, so let me point this out. The summation of d squared is not equivalent to the summation of d quantity squared. If calculated correctly, our sample standard deviation should be 5.13. Now we have all the pieces we need in order to calculate our test statistic. So our test statistic, d, is going to be equivalent to our average difference minus mu of d divided by our standard deviation divided by the square root of n. By plugging in, this will be negative 6.33 minus 0 divided by 5.3 divided by the square root of 6. This will give us a t-value of negative 3.14. Now we can move on to step 5, the p-value. So we're going to want to find the probability that t is less than or equal to negative 3.14. Now remember that less than is coming from our alternative hypothesis of mu d being less than 0. If it had been greater than 0, we would have been trying to find the probability of t being greater than or equal to negative 3.14. So by our symmetry of the t distribution, this is going to be the same as the probability of t being greater than 3.14. So by looking at our t table along our row for our degrees of freedom n minus 1, which is equal to 6 minus 1, which equals to 5, we're going to try to find 3.14. Notice that 3.14 is between 2.571 under our column labeled 0.025 and 3.365 under the column labeled 0.01. So that means our p-value is going to be somewhere between 0.01 and 0.025, which in either case means that our p-value is going to be less than or equal to our alpha value of 0.05. So our decision then is going to be we reject H naught if our p-value is less than or equal to alpha. Our p-value, as I stated before, is between 0.01 and 0.025. Our p-value is going to be clearly less than alpha equal to 0.05, so therefore we will reject our null hypothesis. Step 7, stating our conclusion, we can say that at the 5% significance level, the data indicates that brand A tires wear out less quickly than brand B tires, meaning brand A tires last longer than brand B tires on the average. Assumptions for this will be that we have a random sample of independent observations from a normal distribution. Generally speaking, this is a given based on the wording of our example. Okay, so that concludes our first case. Let's take a look at our second case, our large sample. So taking a look at an example, a random sample of 36 persons was put on an exercise program to improve strength. Before the program, each person's strength was measured. After 10 weeks of exercise, each person's strength was measured again. Did the exercise program result in an increase in strength? Use alpha equal to 0.01. Note, pair difference arises naturally in before and after studies. Note 2, we will compute the differences as D equals after minus 4 before each person. Therefore, a positive value of D would indicate a gain in strength. Using our steps to calculate our to test our hypothesis, step 1, our null hypothesis would be mu D equal to 0. This would indicate there's no change in strength. 2, our alternative hypothesis would be mu D is greater than 0. We would have a significant change in strength, increase, hopefully. Step 3, we're going to have alpha equal to 0.01. Step 4, calculate our data and calculate our test statistic. So same as we did for small data, we have our subject numbers before and after data, and then our last column will be to calculate our differences. From our sample data, we can compute our sample difference mean and our sample difference standard deviation. In this case, our mean sample difference is going to be 2.2, and our sample standard deviation will be 4.5. Using these, we can calculate our test statistic. Using the same formula as above, we can have t equal to d bar minus mu d divided by sd divided by the square root of n. Plugging in, we get a t value of 2.93. This leads us to the end of step 4 and the beginning of step 5, finding the p-value. So we're going to try to find the probability of getting 2.93 or larger for the value of the test statistic, if indeed our null hypothesis is true. So the probability of t being greater than or equal to 2.93. Now, because this is a large sample size, we can change our t into a z and try to find the probability of z being greater than or equal to 2.93. Using our z table, we know that would become 1 minus the probability of z less than 2.93, which is equal to 1 minus 0.9983, which is equivalent to 0.0017. This concludes step 5. Looking at step 6, we need to make our decision. We know that we're going to reject our null hypothesis if our p-value is less than or equal to alpha. Since our p-value is 0.0017, that is clearly less than 0.01. So we are going to reject our null hypothesis. This will allow us to make the conclusion that at the 1% significance level, there was an increase in strength due to the exercise program. Special note, since n is large, no need to assume data comes from the normal distribution. We can pretty much already assume that, as we know, thanks to the central limit theorem, that our large samples will eventually become the normal distribution. Okay, so that brings us to the end of section 6.8. Don't forget to do your homework, and if you have questions, make sure you email me.